Lesson 6.2, one-step equations with rational coefficients. We're going to talk about standard 7.EE.4, which is the essential in standard 7.EE.4, EE standing for expressions and equations. The essential question is, how do you use one-step equations with rational coefficients to solve problems? So what we're going to work on is writing and solving one-step equations with rational coefficients. And the key understandings are that inverse operations undo each other, addition and subtraction are inverse operations, as well as multiplication and division are inverse operations. When you're solving an equation, the inverse operation must be performed on both sides of the equal sign to maintain the equality. And to solve an equation, it's necessary to isolate the variable. Using the inverse operations here, you can see that they have x plus 3.2 equals negative 8.5. So what we do is we're going to, as a technique, keep the line here. We have a positive 3.2, so they subtract 3.2, and what you do on one side of the equal sign, you have to do on the other side. So if we subtract 3.2 here, we subtract 3.2 here. So then this becomes x plus 0. Of course, x plus anything equals itself, so that's x. And a negative 8.5 minus 3.2 is negative 11.7. So if we were to put this back in, negative 11.7 plus 3.2 would equal negative 8.5. So if you remember your integer rules, you'd go through that for addition of a negative and positive numbers. Also, you can verify that on your calculator. So here they have another example. Negative 2/3 plus y equals 8. This is the constant. I talked about that in the 6.2 background video. So to get rid of a negative constant, we're going to add 2/3. What we do on one side, we have to do on the other. So I'm going to add 2/3 to the 8 over here. A negative 2/3 plus 2/3 gives me 0. 0 plus y is y. 8 plus 2/3 is 8 2/3. Again, if you put this back into the equation, negative 2/3 plus 8 2/3, you'll get 8. Here's another example. 30 equals negative 0.5 times a. Well, negative 0.5 times a, the opposite of multiplication is division. So this line here becomes our division. So negative 0.5, I divide by negative 0.5. What I do here, I have to do on this side. So I take 30 divided by negative 0.5. A positive divided by negative gives me a negative. And 30 divided by 0.5 would be 60. So if you wanted to prove that out, you take that, you put it back into the equation, you do the calculation, and you'll come up with 30. And then one last example that they show is using division. So Q is divided by 3.5, and that's a negative, and they're saying it equals 9.2. So the opposite of division is multiplication. So what you're going to do is you're going to multiply, and this really becomes negative 3.5 over 1, because then these two cancel out. The negative 3.5 and the 3.5, the negatives, they cancel out. We're left with just Q over 1. On one side of the equation, I do on the other. So I take 9.2 times negative 3.5, I do the math, and I want to get negative 32.2. If you were to substitute that back into the equation, you would have negative 32.2 over 3.5. And that would be a negative, because remember, this is a negative here. And if you did the math, you're going to equal 9.2. So here's the constant. This is the z variable, and that's a constant. So we have to get rid of this. Minus 4.9, because that's a positive. So that becomes 0. So 0 plus z, and then that's going to be the negative 9 minus 4.9, and that's going to equal negative 13. So if I were to put that back in here, for z, meaning if I was going to take this, 4.9 plus negative 13.9 will give me a negative 9. Same things over here, except instead of, this is a subtraction instead of an addition. So the opposite of a negative 17.1 is I want to add 17.1. What I do on one side, I have to do on the other. Add 17.1 over here. Remember to line everything up. It's kind of difficult with my pen being able to do this, but make sure you have this all lined up and do the math, and that's what R would equal. Over here, this is negative 3 times c. I'm going to, the opposite of multiplication is division. So I'm going to divide by negative 3. What I do on the one side, I'm going to do on the other. So this becomes a positive divided by negative. So my answer is going to be negative. 36 divided by 3 is going to be 12. So the answer is negative 12. Negative 3 divided by negative 3 equals 1. So that becomes 1c. So c is going to equal negative 12. So here they're giving us some more information to be able to help in some real world situations. One thing they're trying to point out too is when you increase your elevation, you're moving in a positive direction. When you decrease your elevation, you're moving in a negative direction. So a scuba diver is exploring at an elevation of minus 12 meters. As it rises, she plans to stop and rest briefly at a reef that is at an elevation of negative 4.55 meters. What is the vertical distance between that they'll travel? I like here that they've created this picture, and this is something I'd always recommend. You're not always going to be given a picture, so if you try to help draw a picture to help yourself out, maybe that might help out. So elevation, of course, at sea level, you're always at 0, and they gave us that we were at negative 12.2, so I'm just going to put this down here. So that's where the diver was. Okay, and then she's going to rise to somewhere, I don't know, right about here, which is at negative 4.55. Okay, so this tells me this is where we started at. Okay, right here we start, and this is where we're going to finish. So we got to find out what this distance is here. So negative 12.2 plus x equals negative 4.55. So we're going to isolate the variable. So we're going to add the 12.22, which is the opposite of the subtraction. What we do on one side of the equation, we do on the other. So negative 4.55 plus 12.2 is going to be positive 7.65. And that makes sense because we rose going in a positive direction, and that's the way we can find what our vertical distance is. So a lot of times we can use this model over here. So this is just kind of like a hand sketch of what they did over here for you that you're not going to be able to use. If we look here, an airplane descends 1.5 miles to an elevation of 5.25 miles. Find the elevation of the plane before its descent. We kind of draw ourselves a map, okay? It descends 1.5, so that means it's going to go down. And it's going to go down 1.5, that's going to be a negative, to an elevation, so I'm going to put this as an elevation of 5.25. Now that's positive because an elevation, of course, this would be sea level here, all right, and that's positive. Find the elevation of the plane before its descent. So we're kind of looking right up in here. Where was it at? This is going to be my x. I don't know what it is. So I'm going to have x. It's descending minus 1.5, and that's going to equal 5.25. And then you can go ahead and use the one-step equations to figure out what x is going to be. For multiplication and division in example 3 here, they're telling us between 10 p.m. and 6 a.m. the temperature is going to decrease at an average rate of 3/4 of a degree per hour. So that's unit rate. Unit rates are usually going to be your coefficient in front of a variable. So then how long in hours and minutes will it take for the temperature to decrease by 5 degrees Fahrenheit? So we're going to have to write this expression. They're going to let x represent the number of hours that it takes to decrease by 5 degrees. The 5 degrees, that's a negative 5 on one side, and this is the unit rate. When you see a coefficient, you usually can look at that as the unit rate. So negative 3/4, because it says decreases an average of 3/4 of a degree, okay, per hour. We're going to take the opposite of multiplication. So I've redrawn this over here because I'm going to show you, like when you looked in the background information for 6.2, on how I ended up doing this. This is multiplication, so negative 3/4. If I just divide that by negative 3/4, okay, we know that that's all going to cancel out because anything divided by itself is going to equal 1, and I bring my x down, so I got 1x, okay? But what I do on one side, I have to do on the other, so negative 5 divided by negative 3/4. Rewrite it, negative 5, and that's a whole number, so I'm going to put it over 1 to make it a fraction. Turn my complex fraction, that's a complex fraction, into negative 3/4. Do my KFC. Negative 5 over 1 times 4 over negative 3. If we go back to this here, what they've done is they've already taken this and showed you the steps. Well, they didn't show you the steps. They just took you here because they're assuming that you already know that. So if I go back through here, I know if I multiply straight across, okay, so negative 5 times 4 is going to equal negative 20. And then 1 times negative 3 is going to equal negative 3. A negative times a negative is going to be a positive. So it becomes 20 over 3, just as we have over here. So x equals 20 over 3, okay, 6 2/3. Well, 2/3 of an hour is 20 minutes for each third, and that gives you 40 minutes. So when I take a look at this, knowing all the things that we know about it, the value of share of stock decreases at a rate of $1.20 per hour, so that's a negative, during the first 3.5 hours. Write and solve an equation to find the decrease in the value. Okay, intuitively, I would say that, okay, if it's going to be $1.20 per hour for the first 3.5 hours, I would set it up as $1.20 per hour times 3.5 hours would equal X. My hours are going to cancel out, and I would take the $1.20 times the 3.5, so I got a negative times a positive, and that's going to end up equaling a negative $4.20. That's going to end up equaling negative $4.20 over that 3.5 hour time period. So here in the guided practice, they're saying that we're going to let how many degrees warmer is the average temperature in November than in January. So intuitively, we just look, well, okay, we're going to try to find what the difference is between these two, but we have to write an equation, and they kind of have it set up. So let X represent the average temperature in November than in January, so that's X. So we're going to just say X plus January is going to equal November. You can put in those values there. Intuitively, what we would do is we would do, November minus January, and that would tell us what our X is. So we would do negative 1.7 minus negative 13.4. And you would find out then that difference. It's asking how many degrees warmer is the average temperature in November than January. So then it's actually an increase because January is colder than November. So you would expect to have a positive answer here. So I hope that helps you out. Got any questions? Let me know.